Welcome to the second video tutorial on BoardOff Design Tool. In this video we're going to be doing a deep dive into one of the sections, in particular the outline generation part of BoardOff. The goal of this is to introduce you to the color conventions that are used on the worksheet so that you'll know where the appropriate places are to change parameters. To introduce you to the concept of how the outline is divvied up and how the parameters that you change have an impact on that. And then finally, to take you through an example of creating a particular outline so that at the end of this, hopefully you'll feel more confident in having a crack at this yourself and feeling a little bit more oriented with what you need to change in order to get the particular outline that you're chasing down. So before we do a dive into the specific parameters and what they do, I'd just like to give a general orientation of the different sections on this page, because there are a number of interacting sections that can be a bit confusing when you first look at them. So first up, in the corner here we've got the draft outline, which, as the name suggests, is the outline that reflects the current parameters that you've configured, or rather the current parameters that are loaded into this grey column of numbers sitting down here in the bottom half of the window. So you'll see that this window is split in two so that you can scroll this independently and not lose the visual design tool up there. So these grey parameters, and we'll go into details of what they are in a moment, are being sucked up and displayed in the chart at the top there. Now, a colour convention that's used throughout BoardOff is that grey cells you should avoid changing. The reason being that they're used in different calculations throughout workbooks, and so not just this sheet that you're on, but various places in the other workbook. And the other colour convention is yellow cells. Anything coloured yellow is designed to take user input, so you can feel quite free to go ahead and change those as you like, experiment with it and see what they do. The general flow that we've got set up here is set up to allow you to save templates of parameters for your boards. So saving columns of parameters that you configure when you're working on a particular design. Those parameters or templates are over here, saved in the columns in a Save Template section. And you can see that when you download this, it comes preloaded with a few, some copies of some commercial boards outlines, some boards that I've worked on myself, and then some that have been contributed by users of BoardOff. What happens is when you want to when you want to load one of those templates and have it reflected up here in the draft outline, all you do is you go to this cell template selection, C34, type in the number of the template that you'd like to see displayed. So in this case I'll select 1, which is the Cabrini Caliber lookalike, and then you'll need to press F9 to actually get all those numbers to flow through. The reason for that is that there's a lot of formulas in the workbook, and so I had to set the calculation to manual to avoid there being these long drawn out delays when you change the parameter. Well, that all flowed through the rest of the workbook. So when I typed F9, you'll see that the draft outline up there and has now changed. Before we had the squarer lunacy-like board, and now when I type in the caliber-like one, you can see you get inverted tips, a squarer corner, and obviously a much narrower tip there. Savable templates are set up in each of the sections throughout workbooks, so the rocker concave, and the flex testing. And so this same sort of layout is used there as well, where the columns, templates are saved in columns. The data is pulled into a selected data section, which will be coloured grey, and that'll be reflected in whatever visualization tool there is. Up in the corner here we've got the compositing tools. What compositing does is allow you to overlay multiple designs on one chart. It does this quite simply by taking a snapshot, so converting your chart to an image and then making that image the background for the chart. The result being that if I take a snapshot and then go and change the template that I'm using, the new outline will be rendered according to the template that I've selected, but because the image is held in the background now, what you'll see on the screen are both those images superimposed on each other. And then just before we move on and do a dive into the detailed parameters, I just want to run through these particular items here because they do stand alone, and so it's good to introduce them up front. Template selection we've already saw, that pulls in one of the saved templates over here. Export grid. This only affects the exported or printed version of the outline that you'll use once you get to the end of it. The grid is the diamond grid that you may remember from the first video that's designed to help you make sure that you've got all the A4 sheets aligned in the X and Y direction if you're going down the path of printing this out on an ordinary printer and not taking it to your local friendly building plans printer. The next one down is titled Reduce Outline for Rail Width. As the name suggests, if you're designing a board with particular dimensions, you have to take into account that the rails have a width as well, and so the core that you're going to want to produce has to be reduced down to take into account the width of the rails. So for example, most of my boards have had a 10mm width rail because that's the size of the router bit that I've got for cutting stuff out. And so I do my design work, and then just before exporting I'll change that to yes, so reduce the outline for the rail width, and that will then give me the right size core template to print out. Next one down is fin inserts, and again you just select yes or no in this cell, press F9 to make it happen. Now, as the name suggests, fin inserts will appear on the screen. Here they only appear as a sort of oblong shapes with round edges. When you actually export it, there'll be crosshairs at the centres of those rounded ends. Now, you don't have to obviously have a full section carved out like that. You can just drill holes on those centre lines. Show footpad inserts. This, as again, hopefully intuitively, puts down two parts of the footpad layout. The two parts are the location of where the where the holes will go for your inserts, and those are the ones that are down here closest to the centre line. And the other set of crosses, which are laid over the top here, represent the corners of the footpads based on the dimensions that you put in this list of parameters down here. Now, the reason it looks a little bit unusual when you first see it is because we're just working with a single quadrant of the board. Everything that would appear in the lower half, so below the horizontal axis, is reflected up into the upper part of the screen. So this, and that's why these fin inserts here, for example, should actually be down below here, and then with the footpad going out in this direction, you can then see how these crosses correspond to those. So these crosses, in particular red ones here, would correspond to the bottom of the footpad being reflected up. And then the final one down here is called control points and gradient ants. I'm actually going to leave that until I've introduced you to the outline, to the way that the outline is structured. Those terms will make more sense once we've gone through that. So I'm just going to duck over and introduce you conceptually to what we're doing with designing this outline. This chart's in the intro if you want to spend a bit more time looking at it. And what it is just a snapshot of the outline draft that we saw on the previous page, but annotated to show how it's conceptually constructed, for want of a better way. So the first thing to notice about this is that the outline is divided into 4 sections. The tip, which extends from here to the top of the corner. The corner, which is in some sense a bit of the tip cutaway. That's this section here. Mezzanine section, which seemed to be an appropriate word to call this section that runs from the tip through to a midsection, and then the midsection through to the middle of the board. Now these, using 4 segments, really came about by having a look at some commercial boards and working on some intuition that it seemed to be those 4 sections where you needed to have control in order to get some of the outlines. In practice, it's turned out to be not too far away from the truth. I haven't had too much troubles duplicating a number of complex boards, including the Weinmann blunt, which has got quite an unusual outline on it. The other thing which is important to draw your attention to are these red dots that appear on each one of those sections. Those red dots are called control points, or abbreviated to CPs, and you'll see that term along with those names, mezzanine, tip, corner, etc., in the terminology that's used in the outline parameters page. What the control points are just setting where BoardOffs should run a smooth curve through. So it starts at the first, ends at the last one, and then passes on its way through the middle. control point. The particular type of smooth curve, because there's obviously a very large number of ones that could be chosen, go by the fancy name of cubic splines. And they just have some good characteristics that they're useful for boards. They don't oscillate, so it is possible with some types of smooth curve drawing programs to actually get little oscillations in them. Cubic splines are pretty well behaved. So you'll notice that for each section there's 3 control points that relate to it, with one control point being shared between adjacent sections. Conceptually, what you're doing when you change the parameters in the Outline Parameters tab to draw your profile, what you're doing is just putting the parameters that set the locations of those control points. That's really it. Now, the way that we go about setting those control points has been set up to try and make it a little bit easier to understand the amounts that you're working with, because as you walk around the outline of the board, it can get a little bit confusing what your point of reference is if you were just entering raw numbers, so the number of millimeters to the control point and various things like that. But the important point is that there's 3 control points per section. The center control point in the outline parameters is the location of it is determined as a percentage of the horizontal or vertical distance between the beginning and end point. So if, for example, I look at the mezzanine section, here's the start control point, here's the ending control point. This center control point in the outline parameters, its location is set as a percentage of the horizontal distance and vertical distance between those 2 control points. So in this case here, I think it's the X location of this center CP is around about 40%, and the vertical location of it is around about 50%. And it's that relative location of the control points that you'll see in every one of the outline parameters. The location of the ending control points changes a little bit according to which section you're working with, and I'll point those out when we go into the outline parameters, which we're going to do now. So we're now in a position to do a little bit of a deeper dive. Before I do that, I just wanted to show you the last of these parameters, which I didn't show you before, and I'll just turn off everything else to eliminate the amount of clutter. And I've just pressed F9 there. So what you'll see are those control points that I was just referring to there. And they come in gangs of 3, so 1, 2, 3. There are in fact 3 on the corner here, it's just that they're very close in that corner there, so you can't distinguish them. But those are those 3, that gang of 3, and then the midsection gang of 3. What the gradient ants do is the one problem that can come out of BoardOff, and you don't actually see it until you can print it out on a 1-to-1 size, is that there isn't any requirement for it to be smooth across the control point that lies between the 2 segments. So this means you can have a sharp corner appearing between, say, the corner and the mezzanine section, which is often where it happens because you have quite a sharp change in direction there. What the gradient ants represent are the slope of the line either side of the control point. And these also occur in groups of 3, and you'll see that each one of them, if you eyeball it, lines up with one particular control point. So if I'm looking at these ones at the top, in the top left of the corner, what you'll see is that there are very clearly 3 points there. The middle one is the gradient at the control point, and then the one to the left of it, which is so the upper left, is the slope of the last point on the corner, and then the one at the bottom is the slope of the first point in the mezzanine section. Ideally, if these points are spread out as they are in this case, then what you've got is potentially a kink in the corner, because it means that the gradient is not close to each other around that same point. Whereas if, for example, you looked over at the end of the mezzanine section here, you'll see that the points are actually very close together, and that's by virtue of the slope being quite smooth there. So those are really just an aid to getting an idea about whether there's a kink You can get a much closer view up of that in the outline template section, just by zooming in on the graph. That tends to show you how much or otherwise there is on the slope. So I'm just looking at the time, and it seems that I've reached the limit of the amount of time that you can upload to YouTube. So we've come to a natural conclusion on this one, so I'll start another video where we'll actually dive into the parameters and have a look at how they all behave.